Hello, Professor. Today I want to introduce the Lecture A summary. My name is Jiajun Jiang, and here's the agenda. We're gonna start with what is cache, and three main ways that can help the cache connect with the address. The first one is direct mapped cache and fully associative cache, and the last one is set associate cache. And we're gonna introduce the replacement policy and how to write the data into the cache and the performance, and the last one is the source of cache miss. So let's start with the cache. The cache is unchecked memory, and the fast is the most important part, so we use the SRAM. And there's two different type of locality. First one is temporal locality, which means when an instruction being fetched recently, then it will be fetched again soon. A spatial locality means when an instruction is fetched, then the other instruction near the instruction will be referenced soon. The temporal is depends on time. The spatial depends on the address. And how do we use the data in the cache, or how do we write in the data in the cache? And there's several ways to do that. The first one is direct map cache. The main point to the direct map is we can take the least significant bit to decide the address to which cache. We can see the picture. We choose the last two bits to decide the address to which cache because we have 4 caches. So each cache can be used by two different addresses because the last two bits are the same. So the last two bits is 00, which is blue. The number 0 and number 4 will go into the same cache. And there's the how to present in the instruction. We can see the picture. The instruction, if the last 3 bits we use to decide the cache, so we can have 8 different cache because the 2 to the power of 3 is 8. The rest of bit is the tag. In this case, we assume the tag is 8-bit, so the last 3 bits is to find which cache is. Then the rest of the 8-bit is to see the tag is correct or not. If the tag are the same and the valid bit is 1, means it's a hit. So it can use the data directly, and there's no need to fetch the data from the main memory. And how to make the cache more efficient on the locality is to make cache block size larger than 1 byte. The main difference is we set the last 1 bit or 2 or 3 bits. We can make the data can contain more than 1 data. 1 bit is for 2 data, 2 bit is for the 4 data. The way to find the data is just the same, but when we find the cache, the last bit is to decide the data is in the 0 or 1. So the advantage for the direct map cache is very simple to use, and the offset can be computed very quickly. But the disadvantage is also very significant. If we use the address 0 and the address 4 all the time, the miss rate will be really high because when we write the data in the cache, the next time we need the different data, but they use the same cache, so we always fetch the wrong data. And the other cache is empty, so the utility is not that high. So there's a different way to deal with this problem. How to fix the problem is the cache is open for everyone. We can see the example. The number 2 car want to park in the cache, so it can choose any cache it want. The car on the behind only can choose the rest of the cache. We call this method is fully associative cache. The advantage for this method is it is easy for the address to find a cache, and also the cache blocks utility is very good because the cache is open for any address. So we don't need the bit to find which cache is, so the whole address is the tag. But the cons is it will also increase the cache size. And in the worst case, you will have to search all the cache to find the address. So the third method is set associated caches. In this picture, we can see the car have to choose the set it wants to park and then choose the block. You can see the red car is going to the set 2, the green car is going to set 5. And how the car to choose the set is use the direct map cache method. So sometimes there's a lot of car parked in the same cache. So the picture you can see the method is just like the direct map cache, but we add more cache in the parallel so it can increase the efficiency. And then is the replacement policy. There are 3 different types of policy. The first one is random replacement. Second is least recently used, and the last is not most recently used. In most of the time, the least recently used have better performance than the random. And the direct map cache have to be replaced all the time because the cache cannot choose the other cache. So for set associative and fully associative, we want to minimize the future cache miss. And then is write back and write through. The write through is write every single data into a memory. It is simple but very time consuming. And the write back, the data will be write to the main memory when the data is being replaced. But the write back, we need 1 bit to identify whether the block has been updated after load. So we call the bit is a 30-bit. And how do we calculate the performance for the cache? The cache performance is very important because the cache miss will affect the CPI. And there is the average memory access time. We call it AMAT. This is a way to represent the cache is good or not. It indicates how many circles it takes to add the data in the memory on the average. The goal of the caching is to improve AMAT. So we can see the formula. The AMAT is equal to hit time, L1, plus the miss ratio times the AMAT level 2. But the level 2 can be expanded to the hit time level 2 plus the miss ratio level 2 times the AMAT level 3. So it will expand so on. And the source of cache miss. The first one is called compulsory. Means the first access to the block will miss because the cache will be the empty in the beginning. But when we run a lot of instruction, like a million, even billion, the compulsory miss will be very, very low because it will only happen on the first. And the second is called capacity. The cache cannot be contain all blocks accessed by the program. Just like the register, we don't have so many cache or register in the memory. So if we don't have enough space for that, we will cause some miss. The solution is to increase the cache size, but sometimes increase the cache size is not a good idea because we have to concern the other reason like the fetch time or something. And the third is complete, means the multiple memory location map to the same cache location. So just like the direct map cache, if we use the 0 and 4, it will complete because they are used the same cache. And the last one is called coherence, means the other process update memory. But just like many technique we teach, we cannot want all the characteristics contained together. So like if we use the large blocks, will reduce the compulsory miss, but it will increase the miss penalty. And large blocks will increase the conflict miss. The associative reduce the conflict miss, but the associative will also increase the access time. So we have to find a solution. It's like in these 4 problem. We have to find a better performance on the ANAT to acquire a better performance. So this is all my presentation. Thank you, Professor.